minus, or when we look at specific points, we know whether it's plus or minus. Okay, so for that is the general formula. And then for this case, we know we have shear, right? We know we have shear, right? And the shear is due to the forces in Vx over Izz Qz over T plus by Vz over Ixx Qx over T, right? So we know all this information. There's another one which is plus by the torque in the x direction or in the y direction divided by J multiplied by C. And we know that now, if you see a rectangular problem, okay, I would not be able to give you a torque. Okay, why? Is because in 2P, you were not taught how to find the shear stress due to torque for a rectangular beam. Okay, so I will not set a question that has a torque on a rectangular beam because it's not fair. So this, we can drop it out. But if it's a circular, yes, it's so easy. Okay, are we clear on that first? So write out the formula that you have to know first. Your formula is based on the transformation. Okay, I repeat again, the formula is based on the transformation. Okay, so there are two things that you could do first. It's up to you. You can either resolve your forces and your moment first, or you can do your Ixx, your Izz. It's entirely up to you. Okay, so let's do the forces first and the moment. Okay, so from here we can I'm going to view it from the y. Okay, I'm going to view it from now. If there's anything that you are not sure, you can stop me. Okay, and I'm not doing breaks. I'm going up to 9 o'clock. Okay, so we are going to look at yx. Okay, and then if there is yx or yx plane, and then this is our rotation in z. Okay, using the right hand rule. So I'm viewing it now that we have a block. Okay, and then I have direction coming towards me. And this is 600. And then I have a horizontal, which is 1500 times 2. Okay. The element of interest is just a sketch A, B, and C. And the centroid that is important is here. Okay. Right. So now the applied force, so we only consider the arrows, the dots and the cross don't care. So the applied force, right, we know from this view that we are going to have a Vx is equal to 1500 because twice 3,000 pounds, and it's going towards the left. Okay. Now, at the same time over here, if we were to look at thin wall analysis, right? That's what I like to do. So if we view this in the cross-section view, X and Y, right? So we know, sorry, this is Z, not Y. We know that we have Vx coming down. So if we were to design the shear flow, it's going to go this way. So it's a box beam analysis, right? And then and down here. So we know that we are going to see a box beam sort of analysis. Okay. So from here, we have element A, element B, and element C. And this is where we have your element A, element B, and you have your what? Element C. Okay. Then the next thing that we know, we have moment in the Z, right? So the moment in the Z is equal to 1500 times 2. And because the applied force is perpendicular to the neutral axis, right? We take the distance to the element. So we are our distance to multiply this distance over here. So this is 20 inches. Okay. So this is multiplied by 20. So when we use our calculator, so 1500 times 2 times 20 is equal to 60,000. Or 60 times 10 to power 3 pound inch. Okay, so 1500. Yep. And then we know that this is going in this direction. Our moment vector. So this is our moment in Z. So what we can say down here, and it's going to be compression, right? So what we can say is element A, B, and C are going to have compression. Or you can put negative, or you can write down comma compression. Okay. So anything else to do? Nothing else to do. Move on. Okay. So another thing from here, we can see that Py is equal to what? Is equal to 0. Okay. And then we now view this from the YZ plane. Okay. YZ plane. Okay. So when we view from the YZ plane, we now have this view now. Okay. And over here, this is where you have your element A, B, and C. And then we're going to draw a green line to represent our centroid. Right. Then from here, right, we know that this is your, wait, now we are over here. We know that this is your 600 times 2, and you have your dots over here. and these are your 1500. Is it dots? No, yeah, no, crosses. Okay. So again, don't bother about the dots and crosses, just bother about the arrow. Okay. So now you have over here rotation in X. So we now know that our VZ is equal to 600 times 2 is equal to 1200 pound. Okay, and it's going to be in this direction. So now if we were to draw this view, right? So this is X and this is Z, right? Our shear flow is again, so this is our 1200 pounds. So if we now sketch our shear flow, again, it's going to be a box beam analysis, right? We are going to see another of our box beam analysis. Then from here, I mean for now, okay, later we go into more detail. Then we have our moment in X, and that will be equal to 600 times 2, okay, and then the distance now is 25. Okay, so 600 times 2 times 25 is equal to 30,000. Okay, so we done that already. So now the next thing that we're going to look at. So now looking at these equations, right? We know what is Py equals 0. We know this, we know this, we know this, we know this. Okay. Next, we want to find Ixx and Izz. This is where you have to be really, really careful. Okay. So again, I'm going to copy this whole thing. Because if this you get it wrong, you'll mess up your answer later on. So if I were to, so this is my X direction. This now is my Z direction. So if I draw it this way, right? All right. So the first thing we know, we get our dimension in first. So we know that this is 6, right? This is 3. And we know, oh, don't know why it does that. We know this distance over here. So the wall thickness is 0.25. So this is 2.5. And then this distance over here is 5.5, right? So 6 minus 2.5 twice. So it's 6 minus, sorry, 0.25 twice, 5.5. 3 minus 0.25 twice is 2.5. So now we want to do Ixx. Okay, so if we are going to do XX, I'm going to copy this twice. Okay, so later on, you can see how easy this is to make mistake, and also how this is easy not to make mistake, right? So if this is our XX axis, right? This is our XX axis. So this will be our width, right? And then this will be our depth for the XX axis. So Ixx, so the width is 6 d cubed over 12 minus by the internal, the width is 5.5, the depth is 2.5 cubed over 12. Okay. So 6 times by 3 power 3 divided by 12 minus